and welcome to your first video on matter. Now I know you are all very excited to start your studies in biology, and we're going to start at the very beginning. So biology means life, or bio means life. So biology is the study of life. But before we really get into anything to do with biology, we have to look at a little bit of chemistry. The reason being is it makes up things that we study within biology. So chemistry is kind of the basis of everything that we start out with. So just to start out with, everything around you is matter. Matter is anything that has mass and takes up space. The hamburger you had for dinner, the pen you're writing with, the shirt you're wearing, the tree outside your window, everything is matter. Everything that you use is matter. Now, what is that matter made out of? Well, if you had that hamburger for dinner, you ate all kinds of things, living things, like vegetables, beef, which was once a cow, wheat, all kinds of things. But what makes those up? That's our question. Now, if you may recall from previous courses, it is atoms. Atoms are the smallest unit of matter. And that's really what we're going to talk about here in this matter video. So it may be a review, but pay special attention. So in atom composition, first we're going to look at the nucleus. And the nucleus is this center area right here. And when you're looking at that, you see two different colored particles. Well, one, the bluish particle, is a proton. And a proton is positively charged. Then you have the red particle, which is a neutron, and the neutron has no charge, and that's surrounded by these dark blue particles called electrons. Now, when we talk about these particles, we generally call them subatomic particles. The reason being that those subatomic particles, as what I'm saying sounds like, is they're smaller than an atom. So you have billions and billions of atoms in that hamburger you ate for dinner. And we want to know, well, what holds it all together? Is it just more atoms? What's really happening here? Well, as I chew and I digest, what am I breaking? Well, your answer would be chemical bonds. So we put together these atoms using chemical bonds. So chemical bonds, all atoms want a full outer shell of electrons. As you can see here, and as you can see here, we're trying to get this full outer shell. And that outer shell is often referred to as valence electrons. And those valence electrons, we want to have a full shell. The atom wants it. So what it's going to do is it's going to share, give, or take electrons. Now, in this atom here, we can see that it has this nucleus right here. We have two electrons in this inner ring. Now the inner ring is always filled when you get to two electrons, and then it'll go to the next ring. So if we get rid of this one electron here and give it over here, we have a full outer shell. So you may be looking at the other one and you're like, well, wait a minute. There's more than two on that outer ring. And you would be 100% correct. On every additional outer ring, we need 8 electrons to complete the outer ring. So the first one we only have 2, but each additional one after that we have 8 to have a full outer ring of valence electrons. So how do we bond though? What's bonding got to do with all this? Well, it's all about electrons. So as you can see here, we're giving and taking electrons, and here it looks like we're sharing, and we actually are sharing here. This is a CH4 or methane drawing, and as you can see, the carbon is using some of the electrons, and so is the hydrogen. It gives both of them full outer shells. So let's talk a little more in depth about our covalent bonds. So two or more atoms are sharing electrons. So in covalent bonds, it's very important to know that they are sharing their electrons. Not one atom is taking the electron from another. And this is a very strong bond, and it holds together most of the molecules of life. Molecules of life being lipids, proteins, nucleic acids, all kinds of things we're going to learn about. So as you can see, we have a carbon dioxide molecule here, and the carbon is sharing with the oxygen, and when they share those electrons, everyone has a full outer shell. So we are sharing these in order to have that full outer shell. So the green particles here are the electrons that carbon originally has, and carbon only has 4 electrons on his outer shell. So he needs to share. He needs to get electrons somehow. And as you can see, oxygen has 6 in its outer shell, so he needs 2 more. So carbon shares 2 of his, and oxygen shares 2 of his, and we have 2 oxygens sharing 2 of theirs. So everyone has a full outer shell. Now those electrons are going to pass through each different atom, but they will still have a full outer shell. And now we're going to talk about ionic bonds. Ionic bonds are the transfer of an electron which causes a charge. Opposite charges attract to make the compound. So this is a weaker bond than our covalent bond. So remember I said we give, take, or share. Well, remember, covalent bonding was sharing. This is where we give or take. When the shell is transferred, we make an ion. So when we transfer this one electron over to this electron, both of them are going to have a full outer shell. They're happy. But we're going to make an ion. An ion is simply a charged particle or atom. So what we're doing is we're losing or gaining an electron. Remember, those electrons were negatively charged, and we have protons that are positively charged. So if there is an imbalance in our numbers, we now have a charged atom. So those positive ions give away an electron, and negative ions gain an electron. So you may be thinking, okay, I understand this, ion, but what's that got to do with ionic bonds? Well, remember I said in our definition that opposite charges attract. So if you have a negative one and a positive one, they will attract. If you have a negative 2 and 2 positive ones, they will also attract. Our whole goal is to get a neutral charge. So we want all of them to cancel out. Okay, so we talked all about atoms, and you might know that elements have something to do with atoms, but they're not particularly exactly one and the same. So here's the periodic table of elements, and these are all the elements that we have found, scientists know that exist. And an element is simply a substance that cannot be broken down into a simpler form. So each element is composed of millions of the same type of atom. What that means is they have the same amount of protons, the same amount of neutrons, the same amount of electrons. And yes, we have ions, and we have other types of the element, but we must have the same amount of protons, electrons, and neutrons, generally speaking. And this isn't 100% of the time because there is exceptions to the rule, but generally speaking, we must have that same makeup. So a helium atom would have 2 protons, 2 electrons, and 2 neutrons. So why are we talking about elements though? Well, life requires 25 essential elements, and there are actually 6 elements that are most abundant in life. Now, these are the ones we see on an everyday basis. We don't work with them, but we use them on an everyday basis. So we have carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. And you consume these all day, every single day. What do we consume them in? Proteins, lipids, carbohydrates, and nucleic acids. You also may find trace elements that you need, like iron or iodine. We don't get as much of those, but we still do get a good amount. So this is your first video. Make sure you took great notes. Make sure you got all of the pictures that you need, and we will discuss this in class.